All right. So today we're looking at the hypergeometric probability distribution. We know that this is hypergeometric because, well, it says on the top, but also because this is a set number of trials. So a set number of trials, and the number of trials are 6, because a jury of 6 is to be selected. We know that it's dependent. It's dependent because there's a small pool to choose from, unlike the binomial distribution where you're choosing possibly from a vast quantity of items and you don't significantly alter the proportions of objects in there, so your chances of success and fail does not change as you choose items from the pool of items. In this situation, the pool of items is only 20 items. And so when you begin to choose items, the pool is altered each time, little by little, but it's enough to, by the end, to make a dramatic difference in the probability of choosing any one of the two males or females. So when that's the case, we know that it's a hypergeometric. And generally, what you're concerned about in a hypergeometric situation is the number of successes. So the number of successes is the variable that you're kind of being asked to analyze. So over here, I'll make the distribution, the probability distribution. And so we know that the probability distribution is a possible number of all successes and failures. So I'm going to call, it depends on what we're looking at. In some cases, we're looking at males. In some cases, we're looking at females. And so you can kind of flip back and forth. So I'll just call this male and female. Okay. And so looks like we're going to get 0 males or 6 females. Or we could get 1 male and 5 females, just like the other probability distributions. We could get 2, 4, we could get 3, 3, we could get 4, 2, we could get 5, 1, and we could get 6, 0. So remember, if there's 6 trials, you end up with 7 different things here. Hopefully I've got enough space to build this out properly. And then, now, we're going to use our formula to solve this. I guess I can kind of erase this. Well, that's a bummer. Okay, let me just fix this here. 1, 2, 3, 4. There we go. Our formula for each one of these, so that the probability goes here, and we know that the formula is sort of, it doesn't matter the variables, but it's kind of like, A choose B times C choose D over, A plus B choose B plus D. And essentially, what are these things? Well, the A is kind of like how many people are eligible in this first category, and B is the number of actual people you choose in the first category, times C. C is the eligible people in the second category, and D is the people that you choose in the second category. And then the denominator is the total people in the entire group. Choose the total people that the size of the subgroup that you're building. So in this case, this is going to be a 6. So we're building a jury of 6. And the A plus B is going to be 20 because there's 12 and 8 females and males. And then up here, we're going to, do our thing there. So our first category is there's 12 males, and I'm going to choose 0. And then there are 8 females, and I'm going to choose 6. And then I divide it by 20, choose 6. So you'll be familiar with this. We've done these before, but now what I'm doing is I'm just going to go ahead and I'll build the entire probability distribution, right? So 12, choose 1, times 8, choose 5. So divided by 20, choose 6 again, and then it's 12, choose 2, etc., etc., etc. Okay? And you end up with the entire distribution. By the magic of filmmaking, I will go ahead and complete this off screen. There, we have it. So it's all complete. This is the entire probability distribution. Each one of these is the probability of getting this particular combination of males and females. Okay, each one of these is mutually exclusive, meaning I could get 6 females and 0 males, or I could get 5 females and 1. I can't get I can't mix this. I can't get 1 male and 0 males, right? It just doesn't work like that. So the final jury will can be comprised of one of these 7 possibilities. Okay, so now that we've made the probability distribution, that's the second answer here. Create a probability distribution for the number of female jurors who will make it on the jury. Oh, well, actually, I probably should have placed the females on this side here, but whatever. Here's the females, there's the males. It is what it is. What is the expected number of female jurors on the jury? So the expected number is going to be the one here, the probability in this chart, whichever 7 of these probabilities has the greatest probability. Let's say it's this one right here that I'm pointing at with my arrow. Then we would say the expected number is 4 females, right? But that's not how we want to do this, because it could be, well, we don't want to calculate all these, first of all. And then secondly, we actually might get a decimal value. Like maybe the expected value is kind of like somewhere between 4 and 3. So you would say something like the expected value is like 3.8 potentially, right? I'm just making numbers up right now. But so how do we find that though, right? How do we find that? So in order to do the expected value here, what we're going to do is we're going to go ahead and apply the formula. And the formula is essentially what I do is I take the proportion of female jurors, so 8 over 20. Okay, essentially, and then I multiply that by the number of trials, or 6. And this is going to end up giving me the expected number of female jurors. And so I'm going to get 6 times 8 is 48 over 20, right? And what is that going to be? Like 2 point, what is that? 2.4, something like that. Yeah, 2.4. Just pulled up my calculator here. So 2.4, 48 divided by 20. So we're going to get a 2.4. So I was way off before when I was just saying 4. So the expected number of female jurors is sort of 2, but we could also maybe get a 3, right? And so that's why we would say 2.4. Now, you would clearly never actually get 2.4 female jurors, but what does the 0.4 represent? 0.4 represents this idea of you should expect anywhere between 2 and 3 female jurors on your final jury, but 2 is just a little bit more likely than 3 because it's a 2.4. If 3 were more likely, then it would be something like a 2.6 or a 2.8, clearly, right? So that's how we figure out the expected number of jurors of any particular group. All right. Now, what is the probability of getting 3 or more females on the jury? So in order to get 3 or more, I need to get 3. Oh no, that's not the right one. Let me erase this. Let me go ahead and do a different color. 3 or more female juries would be sort of like this area up in here, because this would be 3, 4, 5, or 6 female jurors. And if you've gone and made the entire probability distribution on your test, for example, I would likely, or I will accept basically, you could just kind of say part 4, just be add these up. Okay, if you just let me know that you want the sum of these probabilities here to be the answer to part 4, then I'll, obviously be okay with that, right? So that's number 4. I guess you add up the 1, 2, 3, 4 top 4 rows. Let's do part 5. Here, part 5. What is the probability of getting exactly 4 males on the jury? That's going to be this one is exactly 4 males. So what this one, you could probably write it down because it's just a single. So it's 12C4 times 8C2 divided by 12C6. Oh, sorry, these are 20C6. Oh man, I messed all these up. These should be 20s over here. 20, 20, 20, 20, and 20. Those of you probably noticed that in the video after I did the unpause there. You're probably thinking to yourself, man, Mr. Knapp really messed this up. I'm glad I caught it. These are all supposed to be 20s. Okay. There we go. So that's part 5. So for part 6, let's go with what is the expected number of male juries on the thing, on the jury, jurors on the well, we know that the expected number of females is 2.4. Well, if there's 2.4 females and there's 6 people on the jury, then there should be about 3.6 males, right? Because if 2.4 of them are females, then 3.6 should be males. But again, how do you figure that out? It's 12 over 20, or the proportion of males in the entire group, times the number of trials. And so we're going to get 6 times 12. What is that? 72 over 20. And I'm assuming that that's equal to 3.6. Okay. And so that's our hypergeometric distribution. And really, that's all you really are going to need to do on a test in preparation for the hypergeometric section. These are pretty much all the different types of questions I could ask. I could ask for a specific range, 3 or more, 2 or less, more than 5. So you're going to want to be able to answer different things like that. probability of getting exactly a specific value, okay? And then also the expected number as well, okay? So the hypergeometric is reasonably simple, and that is once you've determined that you have a dependent situation and a number of and a specific set number of trials, then you are ready to go. So it's kind of like, did you act, you know, uh, make sure that you were able to understand the requirements for a hypergeometric distribution or to use it. Anyway, thanks for watching.